Hello, this is Dr. Brown, and this video we're going to continue in our probability unit, and we're going to be talking about combining probabilities, which is on page 282 to 293 in your textbook. First, we're going to start with some definitions. We're going to talk about independent events. Events A and B are independent events if the probability of event B occurring is the same whether or not event A occurs. We have a formula called the probability of A and B for independent events, and it says that if events A and B are independent, then the probability of both A and B occurring, which is written as probability of A and B, is equal to the probability of A times the probability of B. And as we said, probability of A and B is the probability of events A and B both occurring, and P of A is the probability of event A occurring, and P of B is the probability of event B occurring. Let's look at some examples. Ask yourself, are these events independent? You toss a fair coin 2 times. The 2 events of the first toss is a head, and the second toss is a head. Well, these two events are independent because what you get on the second toss has nothing to do with whether you got a head or a tails on the first toss. The next example, B, there are 2 events are it will rain tomorrow in Houston, and event 2, it will rain tomorrow in Galveston, a city near Houston. Well, because these 2 cities are close to one another, if it rains tomorrow in Houston, it's very likely going to be raining in Galveston. So they're not going to be independent events. The third example is you draw a card from a deck and then draw a second card without replacing the first. So let's look at a deck of cards with 52 cards, and you draw one out, and then you draw a second card from the deck that has just 51 cards in. What you draw on the second draw is going to depend on what you drew on the first draw. For instance, if you were looking to draw a king and you drew 1 king, there are only going to be 3 kings left in the deck to draw. So the probability of drawing a king in the second draw is going to be less than it would have been if you hadn't taken the card out. So the first one is independent, the second one is not independent, and the third one is not independent either. Let's do another example. Suppose you have a drawer that has 10 pairs of socks, 6 of which are white, and 7 t-shirts, 3 of which are white. You reach in and randomly grab a pair of socks and a t-shirt. What's the probability you grab a white shirt and a white sock? It would be 6 out of 10 would be the probability of getting a white sock or a white pair of socks, and 3 out of 7 would be the probability of getting a white t-shirt. So you would multiply these 2 together and get 18 divided by 70, which is 9 divided by 35. Another example, you roll a fair 6-sided die twice. What's the probability that you roll 2 ones? Well, the probability of rolling a 1 on the first try is 1 out of 6. The probability of a 1 on the second try is 1 out of 6. So the probability of both happening is 1/6 times 1/6, which is 1 over 36. What's the probability that you roll an even number and then a 5? Well, as you know, there are 3 even numbers on a die. So the probability of rolling an even number is 3/6. The probability of rolling a 5, there's only one 5 on the die, so that probability would be 1/6. So the probability would be the multiplication of these two, which would be 3/36, which is 1/12. Probability of either event occurring. And this is written as probability of A or B. And we have a formula for this. It's equal to the probability of A plus the probability of B minus the probability of A and B occurring. And you can see the event space for event A is given here by this green circle. The event space for event B is given by this blue circle. And the probability of A or B occurring is the area of this circle plus the area of this circle minus the area of the overlapping, because if you just add those two together, you double count the overlap. So that's why we subtract off the probability of A and B. Now, two events are mutually exclusive if they do not share any common outcomes. And if these two events, A and B, had no common outcomes, they would not be overlapping, and of course you wouldn't have to subtract off anything. Let's do an example here. You have a drawer, you got 10 pairs of socks, 6 of which are white, and 7 t-shirts, 3 of which are white. If you reach in and randomly grab a pair of socks and a t-shirt, what's the probability that at least one of them is going to be white? Well, the probability that A be the event of drawing a white socks and B be the event of drawing a white t-shirt. The probability of A is 6 out of 10. The probability of B is 3 out of 7. So the probability of A or B is you add up the probability of A plus the probability of B, which is 6/10 plus 3/7. And then you have to subtract off the product of the two probabilities, which is 6/10 times 3/7. Adding 6/10 plus 3/7 gives you 72 over 70 minus 18 over 70, which is 54 over 70, which is 27 over 35. So the probability that you get at least one white garment is 27 over 35. Another example, suppose you draw one card from a standard deck. What's the probability that we get a red card or a king? Okay, let's think about red cards. Half the cards are red, so the probability of a red card is 26 over 52. There are 4 kings, so the probability of a king is 4 over 52. And if we want to look, there are 2 red kings, so the probability of getting a red and a king is 2 out of 52. So now we can calculate the probability of a red or a king. It's the probability of a red plus the probability of a king minus the probability of red and king. So that's 26 over 52 plus 4 over 52 minus 2 out of 52, which is 28 out of 52, which is 7/13. Always remember to reduce to the lowest terms. Another example, suppose you're giving a test to a group of students and the grades and the gender are summarized in this table. one student was chosen at random, find the probability that the student was female or gotta be. So you need to identify in this table the ones that are female and gotta be. And that's indicated in green in the next slide. The ones that are female are gotta be out of a total of 65 students. So the probability of a B or female is add up 18 plus 10 plus 4 plus 12 is equal to 44 divided by 65, where 65 is the total number of students. Now we have another definition of conditional probability. The probability the event B occurs given the event A has happened is represented by P of B given A. This is read as the probability of B given A. Probability of B given that A has occurred. So here's an example. You're giving a test to a group of students. The grades and gender are summarized below. A student was chosen at random. Find the probability that the student got an A given that he was male. Well, you need to look at the male. There were a total 39. There are 8 got an A. So the probability that the student got an A given he was male is 8 over 39. Now, suppose you're given a test to a group of students and the grades and gender are summarized below. Find the probability that a student is male given that he got an A. So now you look at all the A's and look at the number of males who got an A. That would be 8 out of the total number of students who got an A. That would be 18. So the probability is 4 over 9. Now we have another formula for a conditional probability for dependent events. Events A and B are dependent events if the probability of event B is affected by event A occurring. So the formula for this is the probability of A and B occurring. It's a probability of A times the probability of B given that A occurred. So we got event A occurring, and if B is dependent on that, we need to be able to calculate the probability of B given A. That's best represented by the next example. If you pull 2 cards out of a deck, what is the probability that both are 2s? Well, let's talk about event A, that the first card is a 2. The probability of A occurring is 4 out of 52 because there are 4 2s. That's 1/13. The event B is the second card is a 2. The probability of B given that A occurred, notice that you've already pulled 1 2 out. There are only 3 2s left. So the probability, the second card is a 2, is 3 out of 51, which is 1/17. So the probability of both A and B occurring is 1/13 probability that the first card is a 2 times 1/17, which is a probability that the second card is a 2, given that the first one was a 2. And that is equal to 1 over 221. And that is the section on combining probabilities.